In this screencast, we demonstrate the basic functionalities of our data anonymization tool ARX. What you see here is the main graphical user interface. ARX is project-based, so we first need to create a project. First, we need to load a dataset. ARX can import data from CSV files, Excel spreadsheets, and relational database systems. In our example, we load a well-known extract of the 1994 US Census database from a CSV file. In this view, you can exclude columns from the dataset and specify data types for the selected attributes. These settings can also be changed later in the anonymization process. The purpose of this perspective is to configure the anonymization process. On the left-hand side, you can see the imported dataset at the top, and at the bottom you can select a subset of the dataset that will be transformed in the anonymization process. We will not use this functionality in this demonstration. On the right-hand side, you can see an overview of the attributes contained in the dataset. Here you can specify attribute types, for example whether an attribute is a direct identifier or a quasi identifier, and data types, for example whether an attribute is numeric or a string. Moreover, you can create and edit generalization hierarchies. At the bottom, you can specify privacy criteria and configure the anonymization process. We are now ready to specify metadata about the attributes. In our example, we consider all attributes to be quasi-identifiers. We start with the attribute sex. Next, we create a generalization hierarchy. ARX provides wizards for creating hierarchies for continuous and categorical attributes. As sex is a categorical attribute, we use a wizard that is based on ordering. On the left-hand side, you can create an ordered list of the values of the attribute. On the right-hand side, you can combine consecutive values into common groups. In our example, we combine male and female. Next, we define metadata for the attribute age. As age is a numeric attribute, we first set the associated data type to integer. Next, we create a generalization hierarchy. For numeric attributes, we can use a wizard that is based on intervals. First, we define the range. Note that we use top coding for values greater than or equal to 80. We now define the length of the basic interval. In our example, we choose 0 to 5. Finally, we create higher levels of the hierarchy by merging intervals from lower levels. The resulting hierarchy contains levels with intervals of 5, 10, 20, 40, and 80 years. Moreover, top coding is applied to values greater than or equal to 80. We have already prepared a project in which we have performed this process for all attributes. Please note that hierarchies can also be imported from and exported to CSV files. Moreover, as already mentioned before, the perspective also supports direct editing of imported or generated hierarchies. Next, we define privacy criteria. As you can see here, ARX currently supports k-Anonymity, delta presence, L-diversity, and t-Closeness. Regarding L-diversity and t-Closeness, multiple variants are implemented. A criterion can be activated by clicking on this button. In our example, we use k-Anonymity and set k to 5. We now define the maximal number of outliers that may automatically be removed from the dataset during the anonymization process. We choose 100% because ARX implements models for measuring data utility that will lead to a balanced application of suppression, which means removal of outliers, and generalization of attribute values. If you have stronger constraints, you may define them here. ARX provides multiple additional options for configuring the transformation process. In this tab, you can select and configure the method that is used for measuring data utility. ARX supports multiple methods that can be parameterized with different aggregate functions. In this demo, we use the default settings. In this view, weights can be assigned to the attributes. Increasing the weight of an attribute will tell ARX to try to decrease the amount of generalization applied to it. In our example, we assume that age is more important than the other attributes. In this tab, you may specify whether ARX should prefer generalization or suppression to solve the anonymization problem. We keep the defaults, meaning that ARX considers generalization and suppression to be equally suited for solving the problem. We are now ready to anonymize the dataset. When clicking this button, ARX will classify the complete solution space. This means that for all possible transformations, it is determined whether or not the transformation fulfills the defined privacy criteria. Additionally, ARX computes the utility of all transformations that fulfill the criteria and automatically selects the one with optimal data utility. In our example, the solution space consists of about 18,000 transformations, which have been classified and analyzed in approximately 4 seconds. We are now ready to analyze the result of applying the optimal transformation, which is the transformation that fulfills our requirements and results in minimal loss of information according to the defined utility measure. To this end, we switch to the analysis perspective. The purpose of this view is to allow users to compare transformed data representations to the original input dataset and to assess their suitability for the intended usage scenario. On the left-hand side, you can see the original dataset, and on the right-hand side, you can see the dataset that results from the currently selected transformation. Both tables are synchronized when scrolling. Moreover, equivalence classes are highlighted in the output dataset. At the bottom of the screen, you can see some basic statistical information and further metadata. Statistical information includes frequency distributions and contingency tables. Both information is displayed as raw tabular data and as plots. Here you can see the frequency distribution of the attribute age and how the distribution has been coarsened by applying generalization. Metadata about the input dataset includes basic properties of the dataset such as the number of tuples and an overview of the attribute classification. Metadata about the transformed dataset includes the number of outliers that have been removed from the dataset and the number of equivalence classes as well as their minimal, maximal and average size. We see that for our example configuration, ARX has removed 3,530 of the 30,162 entries in the dataset. Moreover, we realize that although we increase the weight of the attribute age, the automatically determined optimal transformation leads to intervals of size 10. We assume that we need intervals of size lower than or equal to 5 years if possible. We now switch to the exploration perspective to find another transformation from the solution space that better fits our requirements. The aim of this perspective is to allow users to browse the solution space and to organize transformations. This view shows a graphical representation of a subset of the current solution space. Each node represents one transformation. Nodes are labeled with the generalization levels that are applied to the quasi identifiers. The yellow node at the top represents the global optimum. The view supports zooming and scrolling. The filter view allows to control which parts of the solution space is shown. With this table, you can define constraints on the generalization levels of the quasi identifiers. The sliders allow to restrict the set of displayed transformations to those whose data utility lies within the specified range. Transformations can also be added to a clipboard, and comments can be specified. In our example, we add the optimum because we might reconsider it later on. The tab on the right-hand side shows basic properties of the selected transformation, such as its data utility. We now use the filter to search for a solution where age is generalized to intervals of size 5 and which has a data utility close to the optimum. To this end, we utilize the sliders to restrict the set of displayed transformations to those whose utility is close to the optimum. We see that this transformation seems to fulfill our requirements and add it to the clipboard. To determine whether the alternative solution fits our needs, we apply the transformation and return to the analysis perspective. From a quick look, we see that the solution is very similar to the automatically determined optimum. The only difference is that age is now generalized to intervals of size 5. Additionally, the number of outliers has increased from about 3,500 to about 5,000. This corresponds to a rate of about 17%, which we assume to be acceptable for our usage scenario. Finally, we export the anonymized dataset to a CSV file. Note that ARX provides a context-sensitive help, which can be displayed for any view by clicking on the question mark located in the top right corner.